Okay, let's have a look at some functions. Here's a function here. It's a function of x is mapped onto 4x minus 1. This defines the function, so 4x minus 1. Find the value of f1. This is the first one. Well, as you know, you substitute this 1 in instead of the x. So f of 1 is going to be equal to 4 times 1 minus 1. 4 times 1 minus 1, and that's equal to 4 ones is 4 minus 1, which is equal to 3. Let's have a look at the second one, the value of f of a half. Again, you substitute half in instead of the x, so it's going to be 4 multiplied by a half minus 1. So f of a half is equal to 4 times a half minus 1. 4 times a half is equal to 2. 2 minus 1 is equal to 1. So f of a half is equal to 1. If I put a half into this function, I get out 1. What's the third one? The value of k if f of k is equal to 9. So you mightn't be quite sure how to approach this when you first read it, but you do know that f of k is equal to something. You can just put in the k instead of the x. So f of k is equal to 4 times k minus 1. So let's get rid of the minus 1. So I add 1 to both sides. I'm going to get 4k is equal to 10. And then that means k is equal to 10 divided by 4, which is 2.5. But you can put that into your calculator. So you've now solved that particular equation. It says, what is the value of k if f of k is equal to 9? And the value of k is 2.5. What about this last one? What's the value of p if f of p is equal to p? Again, f of p, you substitute p in instead of the x here. So here we go. 4p minus 1 is equal to p, because we're told, what's the value of p if f of p is equal to p? Well, f of p is equal to 4p minus 1, and that's equal to p. 4p minus 1 is equal to p. Subtract p from both sides, gets to 0 over this side, and I get 3p minus 1 is equal to 0. And then I add 1 to both sides, or bring the minus 1 across to the far side. I'm going to get 3p equals 1, so p is equal to 1 over 3. Okay, let's have a look at another question. The diagram shows part of the graph of the function ax plus by is equal to 12. Find the value of a and the value of b. Now, in this function, when 0 goes into the function, 6 is the output. When 4 goes into the function, 0 is the output. These are pairs of coordinates which are kind of belong to this function. Because there's the function, that's the drawing of it, and we're told it's equal to ax plus by is equal to 12. But when 0 goes in as an x input, the output is 6. So I can write my formulae ax plus by is equal to 12. And I know when x is equal to 0, y is equal to 6. So I can substitute in a x equals 0 into here and a y is equal to 6 into here. So let's see what that looks like. I'll do it in black. So, I have a multiplied by 0. That's the x. And I have b multiplied by 6, and that's equal to 12. Well, as you know, a multiplied by 0 is just 0, and b multiplied by 6 is just 6b. So 6b is equal to 12, and that means that b is equal to 2. All right? Now, maybe you can pause the video and think, how would you actually do this bit down here? The input is 4, the x is 4, and the output is 0. Can you do the same thing as we just did a moment ago? Pause the video for a second and have a go. Okay. I hope you got it. That'd be great. So ax plus by is equal to 12. Let's write that down again. I'll do it in amber. So ax plus by is equal to 12. I know that when in this case, when x is equal to 4, when x is equal to 4, y is equal to 0. So let's substitute those into the equation. So I'm going to get a multiplied by 4 plus b multiplied by 0, and that's equal to 12. Always equal to 12 in this function. So I'm going to get 4a plus, this here goes to 0, and that's equal to 12. So I don't need a plus, do I? That's just a 0. So 4a is equal to 12, and that means a is equal to 3. So there's your answer. The answer is a is equal to 3, and b is equal to, what did we say b was equal to? b is equal to 2. b is equal to 2. So if you write your function out now, the function was ax, the function was ax plus by is equal to 12. So we can write our function out. They didn't ask us to, I don't think. They just said work out the value of a and b. But it could go 3x plus 2y is equal to 12. Okay, so that's the function. That's f of x. Okay. Now, let's have a look at one more question. Very similar to what we did in a line a moment ago, except this is a curve, quadratic. The diagram it now has ax squared plus bx plus 4. Find the values of a and b. Now in this case, we know that when the input is 1, the output is 9. So let's work out our equation and see what's going to happen. I'm going to write out ax squared plus bx plus 4. And I say when x is equal to 1, y is equal to 9. So let's substitute that in. So I'm going to go a by 1 squared plus b by 1 plus 4, and the output is equal to 9. Okay? That might be a little bit confusing, potentially, I don't know. The fact that the 9 just appeared here on the outside. Whenever you put a value into a function, what comes out of the function machine is the output. So when you put a 1 into this function machine here, the output is equal to y, is the output. Okay? So let's just simplify this. I'm going to have a multiplied by 1 squared is just a, plus b plus 4 is equal to 9. Let's subtract 4 from both sides. You don't have to do this in red all the time or do it the way I'm doing it now, but just for demonstration purposes. So I'm going to have a plus b is equal to 5. Now that's one equation. Okay, we can't solve that. There's an infinity of solutions for a plus b is equal to 5. But we have another point here. We have when x is equal to minus 2, the output is equal to 6. So again, I'm now going to go, I'll do this in amber. So when x is equal to minus 2, then y is equal to 6. So let's do this equation. I'm going to have, I've got to go back up to check it, ax squared plus bx plus 4. ax squared plus bx plus 4. So ax squared plus bx plus 4. That's equal to my output, my y. So let's substitute the values in now. I'm going to have a multiplied by minus 2 to be squared, plus b by minus 2 plus 4, and that's equal to 6. Okay, my output. So I put it in a minus 2 in for the x's, and the output is the y, that's equal to 6. Minus 2 is my input and 6 is my output. Let's see what I'm going to get now. I'm going to get minus 2 to be squared is equal to 4, so that's 4a. Minus 2 by b is minus 2b, plus 4 is equal to 6. Let's subtract 4 from both sides. I'm going to get 4a minus 2b is equal to 2. Okay, and then we solve that using simultaneous equations. Okay, let's solve that pretty quickly then. We have equation 1, we'll label that number 1, and this one number 2. So I'm not sure how you want to do your simultaneous equations, but I would multiply this equation here by 2, multiply all the terms in it by 2, and that's going to give me, so I'm going to keep track of what I'm doing, 2 multiplied by 2. That's equation 2, I'm multiplying it by 2. So let's do that. I'll do it in green. I'm going to get 2a plus 2b is equal to 10. I'm now going to write down equation 1 underneath it, which is 4a minus 2b is equal to 2. Now you'll note what I did was I've used my simultaneous equation to get the I want to eliminate one of the variables. I've chosen to eliminate the b because I can just multiply this equation here by 2 and I get the same number. If I add these two equations now, the b's are going to eliminate each other. Plus 2b and minus 2b are going to eliminate. So let's add them up, and I'm going to get 6a is equal to 10 plus 2 is 12. that means a is equal to 2. And if a is equal to 2, I then can look at this equation, a plus b is equal to 5. So a plus b is equal to 5, a plus b is equal to 5. That means 2 plus b is equal to 5, and that means that b is equal to 3. So the answer is a is equal to 2, b is equal to 3. That means if you go back up to our equation at the very start, you've worked out that this equation, this quadratic equation, is 2x squared plus 3x plus 4 is equal to y. So that's your equation. You've worked it out. I hope that helped. Okay, see you soon.